Welcome everyone. Today I'm going to discuss about one of my important aspect, which is water solutions. Predict the percentage water the following food has. Water gain liquid 1000 millimeter, food 1200 millimeter, cells 300 millimeter, urine 1500 milliliters, breastfeeding 300 millimeter, exhaling 600 meter, faces 100 millimeter. Calculate the total water gain and water loss. Most common variant, a polar molecules, a hydrogen bond, molecules. This is very good example of water molecules. Fill a glass to the brim with water. How many uh, pennies can you add to the glass without causing any water to run over? Predict actual and explain the status. Place some water on a waxy surface. Why to drop firm? Carefully place a needle on the surface of the water. Why does it float? What happens if you push it through the water surface? Sprinkle peppers on water. What does it do? Add a drop of soap. What happens? Water molecules within water hydrogen bond in all directions. Water molecules at surface cannot hydrogen bond surface pulled inward. Water surface behavior like a thin elastic number or skin surface under hydrogen bonding. Solution are homogeneous mixtures of two or more substances. Solutions the substances in the lesser amount, solvent the substances in the greater amount. Spread evenly throughout the solution cannot be separated by the filtrations can be separated by the evaporation. Not visible solution appearance transparent may give a color to the solutions. Air, gas, soda, CO2 gas in water, gas or liquid. Seawater, NaCl is water solid. Brace, copper and zinc, solid or waste. Give example of some solutions and explain why they are solution. Water, argon, salt water, ART. Water, argon, salt water, ART. Braces 2 gram zinc plus 50 gram copper. Solution zinc, copper. Solvent zinc, copper. 100 gram H2O plus 5G KCl. Solution KCl H2O. Solvent KCl H2O. Brace 20 gram zinc plus 50 gram copper. Solute zinc, solvent copper. 100 gram H2O plus 5 gram KCl. Solute KC1 and solvent H2O. Identify the solution each of the following solution: 2 gram sugars plus 100 gram waters, to 60 milliliters early alcohol and 30 milliliters of methyl alcohol, 55 ml waters, airs. Identify the solution in each of the following solution: 2 gram sugars, 30 milliliter of methyl alcohol, 1.5 gram Nancy and 200 milligram O2. That solvent such as water is needed to dissolve polar solution such as sugar and ionic solution such as NaCl. Solvents such as hexane. Which of the following solutes will dissolve in water? Na2SO4, yes, polar. Gasoline, no, non-polar. I2, no, non-polar. HCl, yes, polar. Hydrogen dissolved solute. Electricity, a substance that conducts electricity when dissolved in water. Acid-based and soluble ionic solutions are electrolytes. Non-electrolytes, a substance that does not conduct electricity when dissolved in water. Molecular compounds and insolubles ionic compound are non-electrolytes. Electrolytes, some solutions can dissolve into ion. Electric charges can be carried. Strongly electrolyte dissolve component good electric conduct. Using chemical equation MgCl2 Mg plus 2Cl. Strong acid AHNO H2O HCl HNO. Strong basic BMOH. All salt dissolved in water are completely ionized. When NaCl dissolved in water, the reaction can be written. You are making a chicken both using a boiling cube water. Some these things can do to make it dissolve faster. Crush it, use hot water and stick it. Sugar it to dissolve faster in enemy iced tea. You need to dissolve some gelatin in water. Indicate the effect of each of the following of the rate at which the gelatin dissolve. The maximum amount of solute that can be dissolved in a specific amount of solvent, usually 100 gram. Stored solutions contain the maximum amount of solute that can be dissolved under undersolved solute remain, and unsaturated solution does not contain all the solute that could dissolve. Solubility, polarity, temperature, surface area, strain, polarity, temperature, pressure. Convert bond and ionic bond are the two main types of intermolecular bonds. Solvent bonding involves the sharing of the valence electricity involved in the sharing of the valence electricity between two atoms. Polar, unique sharing of electricity, non-polar, unique sharing of electricity. Ionic bonding involves the transference of valence electricity. These are the many important aspects of the waters, and we can learn these water things in an effective way. Gas is the bottle built as the gas become less soluble in water and high temperature, which may cause the bottle to explode. Because O2 gas is the less soluble in the warm weather, the fish may not obtain the need amount of O2 for their survival. Show the condition that affect state of the solution unsaturated, saturated, supersaturated. Solubility tables. Find out the mass of the solute needed to make saturated solution 100 cm2 of water for a specific temperature. This is prepared for each of the temperature from 0 degrees Celsius to 100 degrees Celsius. The data is plotted on the temperature or solubility graph, and the points are connected. These connected points are called a solubility curve. Identifying a substance, looking of the interactions of the solubility and temperatures. Located the solubility curve needed and see for a given temperature which solubility it line up with, and vice versa. Temperature will sodium natures have a solution solubility of 95 gram per 100 cm3. So these are the different aspects of the waters, and if we can follow these things, maybe we can understand water and water integrations in the society and in the nature. Thank you. Bye bye and take care.